All right, so let's get going for our final mad dash that we promise will be done by 4:30, and so you'll be able to catch the 5 o'clock tunnel, no problem. Okay. Couple of things. There's extra food in the back. Feel free to take a sandwich and any of the food back there for the road. We really encourage you to take our survey slash evaluation. It really helps us out for future events. I want to thank again our sponsors, Exxon Valdez Oil Spill Trustees, Philanthropy Northwest Thriving Communities Grant Making Program, Chugach Alaska Corporation, Bob and Sherry Dugan, the City of Whittier for letting us use this space, Prince William Science Center for their watch party, Prince William Sound Regional Citizens Advisory Committee, Alaska Sea Kayakers, Alaska Wildlife Conservation Center, Alpine Alaska, Anadir Adventures in Valdez, Chiniga Regional Development Group, Chugach Regional Resources Commission, Colony Builders, Drifters, Fish, Lazy Otter, and the Frisky Mermaid, Stan Stevens Glaciers and Wildlife Tours, and all other sponsors and individual members. Oh, and Coast Pizza. Thank you very much for attending. Thank you all for attending. We'll look forward to next year. We'll be setting a date for next year. Lickety split. It'll probably be about the same time. And also, before we go any further, I got 3 books to give away. So those of you who stuck it out, we have, you'll get your choice if you get my question right. We got geology and 2 books of killer whales of Prince William Sound. So my first question is, where's my questions? I don't know. Okay, here it is. How many private vessels are involved for, or are prepared for oil spill response? Oh, it's all right here. Where's mine? Is that right? I think that's right. 350. Okay, what do you want? You want killer whales or geology? Okay, geology. All right. Okay, next question, real quick. What is the common name of the sea star Pitnipodia? You in the hat, on the end. Sunflower star, yes. Okay. Okay. Who has become a member of the Prince William Sound Stewardship Foundation today? Today. Today, really? All right. Okay. There you go. Stand up. Like it. All right. Okay. So last but not least, we have an update on the Beatson Mine Remediation Project with Jeff Lachowski. Lachowski. Okay.
Thank you. All right, appreciate the opportunity to be here. Tough to follow Jesse. That's amazing work there. Thanks for sharing your talent in a very meaningful way. So as mentioned, my name is Jeff Lachowski. I'm with Rio Tinto. I'm a closure manager with our legacy closure division. Rio Tinto is a very large mining company, but we have a team that specializes in kind of remediation of these old legacy sites that are no longer active, and some go quite a ways back, the Beatson Mine being one of them. So do I have a clicker here? Yeah, okay, awesome. Aim right there. Okay. Let's hope there we are. So I'll just start with this acknowledgement and just let folks read that for a quick minute. Okay, so quick look at the agenda, what I plan to cover. So I want to talk kind of a big overview, big picture look at the project of what we have going on, our cleanup approach on this old legacy mine site. I'll talk a bit about the actual site cleanup plan, which is in conjunction with the Alaska DEC. And then I'll talk about kind of where we are today in this season, which includes a revegetation pilot study, a 60% design, which I'll explain what that means, and then following with our next steps and timeline. So this is a former copper mine. It was a similar timeline as mentioned in the LMR, if I said that right, timeline with mining prior to the 1930s. There was actually 3 separate mines on Latouche Island, the Blackbird, Beatson, and Chiniga claims, and they produced copper from 1899 to about 1930 before the operation was shut down and, kind of the company walked away essentially. So in 1989, Rio Tinto became responsible for these former mine sites. This was a large acquisition. Rio Tinto acquired the Kennecott companies, and at that point, the Beatson Mine subsurface rights were part of that acquisition. So it wasn't on Rio Tinto Closure's radar as a project to manage until 2014, when Alaska DEC contacted landowners and did the research, basically looked back to the company acquisition to where Rio Tinto was now accountable for the subsurface mineral claims at the site. So basically at that point when we got notified, we began characterizing and investigating the mine site to understand the contamination and come up with a plan to manage and clean up the site. So we began that evaluation around 2016, and basically the purpose of the project is to manage the source materials. So there's waste rock and tailings that were left in place and are essentially leaching metals into surface water and groundwater at the site. So we worked with DEC on a slew of alternatives, how to best manage and contain and reduce control the source pollution moving forward. So this is a good slide just showing a bit of some of the main photos and things that are out there. So in the middle, what you see is we call that the tram dump. So that's a large pile of waste rock. So this is essentially overburdened material that was pulled out of the underground. It's natural material, but once exposed to oxygen and water, metals leach out of that and then spread into the surrounding environment. On the left, you have a large fuel storage tank, and you can see the age of this stuff. It's pretty old. It's been in place for almost 100 years now, and a lot of it has kind of been reclaimed naturally. You see a lot of growth and changes in the environment as nature does. The middle photo is a bunch of debris that was partially impacted by the tsunami, as well as a developer in the 1970s who the surface estate was transferred in the 1970s, and a developer actually came in and subdivided the land into parcels, bulldozed a bunch of the old mine debris and infrastructure, and sold the lots. So there's quite a few individual lots out there that we attempted to acquire and basically wanted to gain access to do the remedial work. So I mentioned in a high level the cleanup approach, which is really just to consolidate the waste material, and the idea is to isolate it from oxygen and water. So we would be basically a bunch of earth-moving equipment would bring the waste rock and tailings into a constructed repository, which would have adequate drainage underneath so that the groundwater wouldn't impact the mine waste material. And then the waste would be placed in the middle, capped and adequately covered and drained from the top so you don't have water infiltrating the material. There is some materials that will be left in place and either managed with capping or institutional controls. Some of this is due to just mature forest or inaccessible areas due to safety. And then also there's several mine openings that'll be closed to just basically make sure they're safe for if anyone would wander upon them, there wouldn't be any hazards. And then ultimately everything would be restored and revegetated. So getting up to kind of where we are on the project, this last summer, we did some drilling and additional sampling to basically refine our preferred approach. This was looking at really characterizing the drainage area of the repository, and also just understanding what kind of borrow material existed on site. Unfortunately, we found out that there wasn't a lot of borrow material on island, so we will be sourcing quite a bit of that from off-site. And so all along this process, we've been engaging with DEC and walking through kind of an iterative process with them on the site cleanup plan. And essentially, we've gotten to a point of agreement, and we had an iteration in with them, and we're expecting approval in the upcoming weeks or months here. So that'll be a big milestone. And then with that site cleanup plan approved, we can then proceed to permitting and kind of our final design. So as part of our last season's field work, I mentioned the drilling. You can see the left photo is a drill rig. We did a bit of trials on revegetating in these areas where the drilling had impacted to see sort of experimentally, hey, what'll work here? And then we'll utilize what we've learned in the final remediation. So there's a few species there that we've utilized and are based on, natives to the area and with input from experts. Had some good success there, so that was good learning, and that'll be applied in our final project. So I mentioned the design process, which is, the remedy of consolidating all the material into repository. And we've developed that to a 60% level, kind of in engineering terms. And this 60% level intermediate design will be utilized for our permitting process. We're going to be applying for a Army Corps of Engineers wetland permit. We're proposing the project to be a self-mitigating. Obviously, our effort here to remove this mine waste is going to be a net environmental benefit. So we will be impacting some wetlands, but in the process, it seems like the Army Corps will support the fact that overall the project is a benefit. So we will hopefully get permitted for those wetland impacts to construct the repository and complete the project. So this is just a quick look at the timeline. You can see we're approaching the site cleanup plan approval with the star there, a big milestone. And then the next steps will be permitting. And then if all goes well with permits and our process, we hope to construct over 3 seasons starting in 2028. So there would be 3, field seasons mobilized to do the work. So this summer, we have some additional water sampling, just baseline data collection, as well as some cultural resource survey, and this is to support the permitting process. We're doing that in partnership with Chiniga and Northern Land Use Resource Associates, some local folks here out of Anchorage. So that's on tap for this summer, and then later this fall, we hope to submit our permit applications and progress forward. So then we've got a pretty neat, and some of you have seen this last year, we've updated it slightly, but we've got a really good video that kind of walks through the process. So hopefully this works, but it's a really good demonstration of, if you could just click that, that'd be great, please. Let's see.
Latouche Island and the surrounding land and waters of the Chugach region are the traditional and ancestral homelands of the Sugpiat people. We acknowledge and honor the ancestors, elders, and current generations who have cared for these lands, waters, and wildlife from time immemorial. We recognize that the Beatson Mine is here because of the sacrifices forced upon the Sugpiat people. We commit to integrating their traditional knowledge with our efforts to remedy the impacts caused by historical mining. Since 2016, Rio Tinto has been studying how past mining operations at the Beatson mine site on Latouche Island, Prince William Sound, Alaska, have affected the surrounding environment. The Beatson mine site, located on traditional Sugpiaq land, includes 3 former underground copper mines: Blackbird, Chiniga, and Beatson. These mines were in production between 1899 and 1930 by Kennecott Copper Corporation. The surface interests were sold to a developer in the 1960s, well after mine operations had ended at the site, which Rio Tinto never operated. Waste rock, tailings, and debris from mining operations have been left on site for nearly 100 years. Additionally, a historical flume, or human-made elevated trough, reached across the beach area and disposed mine tailings downslope into the water. Developers in the 1970s also used the contaminated waste rock as road base material, spreading metals contamination farther across the site. The waste rock piles and surrounding soils are a source of metals contamination to the site and are mixed with historic mining debris. These metals leach into groundwater and surface water bodies on site, along with the naturally occurring high levels of arsenic. Water bodies at the site include creeks, a feature known as Mine Lake, which is fed by Copper Creek, and a number of constructed ponds located within the historic mine footprint. Another area of the site was historically used to store heavy oil. This area of the site contains old, weathered hydrocarbons in the soil, but they do not affect the surface or groundwater. Site underground mine openings, referred to as adits, are also present at the site. The main openings include Beatson Main Adit, the Main Adit South, the Beach Portal, and the Chiniga North Adit. These openings also convey contaminated drainage from groundwater and surface water. We're finalizing a cleanup plan and the design to remediate the site and improve the environmental conditions. This cleanup project, led by Rio Tinto, is based on extensive studies to make sure we're safely addressing past contamination caused by the former operator and preventing any ongoing impact. As part of the cleanup, waste rock, debris, and hydrocarbon-impacted soils, as well as tailings that spilled onto the beach, will be consolidated into an engineered repository to prevent metal leaching and to control the primary sources of contamination on site. The process that we use to build the repository would follow these steps. We first remove the organic soils within the footprint of the repository. We construct an under-drained system to keep the waste rock dry from groundwater, and then place the waste rock into the repository. We then sequentially prepare the waste rock surface, install the geomembrane, geocomposite drainage layer, general fill soil, and vegetation soil, and undertake a revegetation program. To ensure the submarine tailings remain stable and undisturbed, institutional controls were approved to manage the submarine tailings. In areas of the site that have been temporarily disturbed due to soil drilling and other field work, we have been restoring and vegetating using plant species native to the region and suitable for the wet island climate. We will continue to restore and vegetate areas disturbed due to cleanup activities. Consolidating the contaminated material in a repository will control the source of contamination and result in improvements of environmental conditions and increased protection of human health.
Okay, appreciate the opportunity to be here. Thank you, and